In this next little section, what we're going to look at is how a negative will affect our graphs, whether the negative is on the outside or whether or not the negative is on the inside of the function. Does matter. So if it's on the outside, then it should be only affecting our y values. However, if we're affecting our y values, this is weird, you're actually going to reflect over the reverse. You're going to actually reflect over the x-axis. And it does make sense when you think about it. For instance, if you have any positive y values, what would happen to those y values is that they would become negative because the negative sign would flip their value. So whatever was up on top that was negative would flip down, and anything that was negative would flip up top and become positive. Notice that motion means that you're actually going around which axis? You're going around the x-axis. So if you actually have a negative on the outside, it actually flips you upside down and flips you over the x-axis. However, if you have a negative on the inside of your function, it's going to do the reverse because it's going to flip the sign on your x's. So whatever was positive will become negative, and whatever's negative will become positive. That means you're actually, instead of going over the x-axis, you're going around the y-axis. So that means you would actually be flipping, instead of up and down, you'd be flipping left or right across the y-axis, even though you're changing the sign on the x values. So be careful. If you're on the inside, you're negative. That actually means you're going to affect the x values, but it actually means when you affect the x values, you actually flip over the y-axis. So, kind of a quick summary is if the negative sign is on the inside, it affects the x values, which flips you over the y-axis. However, if the negative sign's on the outside, it affects the y values, but it flips you over the x-axis. It's a good little summary table for you. So now what we would like to do is kind of group these all together and do a combination of these different types of problems. So let's take a look. So let's take a look at A. In A, we have y equals x plus 2 squared. Because of the squared out on the outside here, this means that we have a parabola shape, a U shape. However, because of the plus 2, that means that it's actually going to be shifted to the reverse of what we think. It's going to be shifted to the left 2. Remember, if it's inside, you do the reverse of what you'd think. We move it to the left 2. So, our points, which are normally at 0, 0, 1, 1, negative 1, 1, those are all going to get shifted to the left 2. So we're going to go over to left 2. That will put us at a negative 2. We'll also notice, as a reminder from earlier in this section, that our stretch, you can't see it, is a hidden 1. So that means we're going to be pulled up 1 on either side. But that's all we need for our parabola, and we'll go ahead and draw our U-shape, our parabola, through those points, and we are done. Now let's take a look at B. In B, we're doing something very similar. We've got a squared graph, so it's still going to be a U-shape. We've got the plus 2 inside of our parentheses, which still means we're going to be going to the left 2. So we're going to be moving it to the left 2. There is a difference, though. The negative that's outside of the squared means that our stretch, instead of getting pulled up, is going to get pulled down by a factor of 1. So what that does, let's take a look, is remember that we're moving our graph to the left too, just like before. It's set for instead of our stretch being pulled up 1 like normal, it's going to get pulled down 1 like normal now because it's a -1. And then we can draw our parabola, but now it's pointing downward because of the negative out in front. Notice it looks like the exact same shape, just pointed downwards because of the negative, which makes sense. We said if there's a negative out in front, what it does is it flips it over the, even though you're changing the sign of the y values, you're actually going to flip over the x-axis, means we flip upside down. Let's take a look at this next one. On this next one, we've got a square root graph, at least to start. Normally, the square root graph goes through 0, 0, 1, 1, and looks something like this. The question is what that negative will do. Now, it is very important that that negative is on the inside here. Because the negative is on the inside, it's going to switch the signs of the x values, which means this x value, which here is at +1, when we switch the sign because of the negative, it will actually put that same point over on the other side at -1. Which means the 0, which was already not positive or negative, will stay the same. Any points that were at, like the next point should have been at, when you take the square root of 1, 2, 3, 4, you get 2. Should have been another point. So would now be at 1, 2, 3, 1, 2, 3, 4. Should be at -4, 2. Because you're only changing the signs on the x values because this is on the inside. So notice what happened. Our final graph here, which is highlighted, has changed all the sign on your x's, which actually meant you actually flipped over. Well, what did you flip over? You flipped over the y-axis, even though you switched the sign of the x values. So your final graph here, which is highlighted, is this guy, the pink graph. Let's take a look at D. In D, we've got another square root graph. Again, let's start out by drawing the regular square root graph. It goes through 0, 0, 1, 1. And if you do want another point, it also goes through 4, 2. Okay. Now this time, notice that the negative is out in front, outside of the square root. That means our y values are going to switch their sign because it's on the outside, which means our y values, which are at 1 and 2, are now going to be at 1, -1. Let's see, -1 and -2. So they'll still be at the same x values at 1 and 4, but their y values will now be negative. So our final graph will be this graph. And again, notice the point at 0, 0 will not change because 0 is not positive or negative, so it will stay the same. So that's our final graph there, is the purple graph. And notice what happened is when we switched the sign on the y values, it actually flipped us over the x-axis. But that's our final graph. Let's take a look at E. In E, we have a squared graph again, which means we've got the U shape or the parabola. We've also got a +5 outside. That means we're going to be shifting the graph up 5. And be careful, we also have a minus or a -1 out in front of our x squared. It's not inside of the x squared, it's on the outside because there are no parentheses. So that means that's going to flip us upside down. So let's see, or be a negative stretch. So the first thing that we look at is our normal parabola goes through 0, 0, 1, 1, and -1, 1. That's the normal, just without anything done to it, x squared graph. Well, now the plus 5 is going to shift everything 1, 2, 3, 4, 5 units up. So just by shifting it up 5, we'd end up with the following graph. However, that still doesn't deal with that negative or -1 that's out in front. We can't ignore it. So what would happen, instead of this stretch up 1, we'd actually have a stretch down from where we're at of 1. So that means that our points would be on either side, down 1 instead of up 1. Just like before when we did this, that center point, because it was originally 0, does not change. So this is what our parabola will look like. Almost the same exact thing, it's just the stretch is pulled down 1 from where it was instead of up 1 from where it was. Let's take a look at the next group. The next group is a tiny bit more complicated.